Today on Capechi's Corner, we're going to look at roots and zeros. So we're going to start with a little bit of a review problem that's going to lead us into our lesson for today. The directions say to solve the equation. We're going to list all the real and imaginary solutions, which are the roots, and then we're going to state the number of each type of root. So the first thing I'm going to do is going to factor out the greatest common factor, which is x, and I'm left with x squared plus 25 is equal to 0. Now, in this case, because of the zero product property, x is going to equal to 0, or x squared plus 25 is going to equal to 0. So we already have that x is equal to 0, so that's going to be one solution. I bring that 25 to the other side, take the square root of both sides, so x is equal to plus or minus, and this is going to be 5i. So in this case, there are 3 roots, right? We have 0, and then we have plus or minus, so we have 3 roots total. This 0 is a real root, so we have 1 real root. And because of the i's here, and we have plus or minus, and then we have 2 imaginary roots. Okay, we're going to need those roots as we kind of go forward in this lesson. So we're going to talk about Descartes' rule of signs. The wording for this is a little bit tricky, so we're going to actually come back to it. We're going to work on a problem, and then we're going to come back to it, okay? And we'll kind of talk about it in the first example. So first thing we have to do is we have to state the possible number of positive real zeros, negative real zeros, and imaginary zeros. And what that has to do is the number of times the signs change in the given polynomial. So right here, this goes from positive to negative, so there's one change. Then we have negative and negative, so that's not a change. Let me go negative to positive, that's a change. Positive and negative, that's a change. Negative and positive, and again, that's a change. So we have 4 sign changes. So what that means is we can have 4 possible roots. Now, because of this 4, now we can also have more than that. And this is where we go back to Descartes' rule. Okay, so the number of positive real zeros, which is what we just talked about, is the same as the number of changes in sign of the coefficients of the terms, which is what we just talked about, or less by an even number. So what that means is, because this is a 4, we're going to have 0 possible positive roots, or it's going to go down by 2. 2 and then down by 2 one more time, 0. So there are 4, 2, or 0 positive roots. Again, because of that sign change. Now we're going to do the same thing. This was positive x. We're going to do the same thing with negative x. So we're going to have to clean this up just a little bit. If I took negative x and I took it to the 6th power, remember this is negative 1. Negative 1 to the 6th power would be positive 1. So that is going to give me positive x to the 6th power. This again is negative 1 to the 5th power, which would give me negative 1. Negative 1 times 3 here gives me negative 3. X to the 5th. This would give me positive, and I have that negative 4 out front, negative 4x to the 4th. This would give me a negative, and I had negative 1 times negative 6, which gives me positive 6, x to the 3rd. And this would be positive x to the 2nd, plus 8x plus 5. So that's when x would be a negative value. So now again, we're going to check out the number of sign changes. So we have a sign change here, a sign change here, and then that's it. Okay, so we have 2 sign changes. Now, because of that, we could have 2, or again, because of Descartes' rule of signs, or 0, we're going to go down by 2 negative roots. Now, again, if we go back to the beginning, now again, this right here and this right here was the same function that we started with. We just substituted either x or negative x. So the highest power there is 6. So the total number of roots I should have is 6. Okay, so now it says we want to state the possible number of positive real zeros, negative real zeros, and imaginary zeros. Remember, the zeros are the same as the roots. So in order to do that, we're going to fill out this chart over here. Now, positive real zeros, we said, could be 4 is the most. So I just think if you do a pattern, it's going to make your life a lot easier. We know we have to add up to 6. So when we add these 3 numbers, we should add up to 6. Okay, I could have 2 negative real roots. So if that's the case, then I would have to have 0 imaginary roots again, because that number has to add to 6 because of our total number of roots here. I could also have 4, and I could have 0 negative roots, in which case there would have to be 2 imaginary roots. Okay, that would be the only option when my positive roots are 4. Now I'm going to go to 2. I'm going to do a similar type pattern. I could have 2, and again, I could have 2 or 0 here, 2, and that would make that 2. If I had 2 again and gave that a 0, then in this case, this would have to be 4 imaginary roots. And the last thing I'll have to look at is my number of positive roots is 0, in which case I could have 2, and this would be 4, or 0, 0, and 6. Okay, so again, all of these rows, when I add them up, they're going to equal to 6. So when I'm answering this question, how many should I have? Could I have my positive real zeros? So positive real zeros would either be 4, 2, or 0, right? Looking at this. My negative would be 2 or 0. And again, you're going to get that up top here as well. Same type of thing. We're only going to add this imaginary to our list as well. And if you look at our numbers here, it could have anywhere from 6, 4, 2, or 0. Okay, let's try another one. Same thing here. I have x, the positive x is substituted into the number of sign changes I have. I have 1 here, and I have another one here. So it's 2 sign changes. 2 sign changes. So I'm either going to have 2 or 0 positive roots or zeros. Now the same thing, I have to clean this up a little bit over here. Remember, this is -1. -1 to the 4th power would be +1, so that's x to the 4th. This becomes positive. That -18 is going to be multiplied by a positive, minus 12x plus 80. So in this case, I have 1 sign change here and 1 sign change here. So I have 2 sign changes. So again, I could have 0, 2 or 0 negative roots. Okay, so I'm going to fill out my chart. So I could have 2 positive roots, 2 negative roots. Oh, sorry, the total number of roots here, my highest power is 4. That's going to be 4 there. In this case, my imaginary roots would have to be 0. I could have 2 positive and 0 negative, which would give me 2 imaginary. And I'll do the same thing with the positive, 0, 2, and I'd have to have 2 here. And if I would 0 here and 0 here, I'd have to have 4 here. Okay, to answer my question, again, I could have positive roots would be 2 or 0. My negative roots would be 2 or 0 also. And my imaginary roots would be 4, 2, or 0. We're going to look at the complex conjugates theorem. And basically what that says is, if I have, we're going to be dealing with some imaginary numbers. If I have a plus bi is a 0 or a solution, then I'm also going to have a minus bi. So for example, if you look at this, if I give this as a 0 or a solution or a root of a given polynomial, then 3 minus 4i is also the 0. So if you have a plus, you're also going to have that minus. So what we're going to do here is we're going to write a polynomial function of least degree with integral coefficients, no fractions, the zeros of which include, so it's this, -1, 5 minus I, and because of that theorem we just talked about, we're also going to include 5 plus I. So basically, we're working backwards, and we're trying to get to a polynomial that looks something like that. We don't know how many terms it's going to have yet. So if these are solutions or zeros, then this first one's going to be the opposite sign, right? X plus 1. Because remember, if we set that equal to 0, then x plus 1 would equal to 0. So x would equal to -1, which is what we have there. So that's why we use the opposite sign there, x plus 1. Now, with the imaginary numbers, it gets a little bit tricky. So I'm going to have x minus, and then we can even make this a bracket, in parentheses 5 minus I. And then we're going to do the same thing over here, x minus 5 plus I, parentheses and a bracket. So we're going to deal with these two binomials right now. This x plus 1, we're just going to keep rewriting that one. Okay, so in this case, I have a binomial times a binomial, so I'm going to use FOIL. Okay, so x times x is going to be x squared. My outside, I have x times negative, and in parentheses 5 plus I. So that's going to give me negative x, right? Times 5 plus I. And then my inside terms is going to be the same thing. X times negative 1 is negative x times 5 minus I. My last term, negative times negative, gives me a plus. And then I have 5 minus I times 5 plus I. And this is one big bracket. Now we're going to need a couple steps to kind of clean this up. So I'm going to rewrite that x plus 1. Now in my bracket, I'm going to take this, and that becomes an x squared. I'm going to distribute that, so it gives me negative 5x. And take the negative x times positive I, so I get negative ix. And I'll do the same thing with the next set of terms, and that gives me negative 5x. And this time I get plus ix. And then I'm going to use FOIL here. So 5 times 5 gives me 25. My outside gives me positive 5i. My inside gives me negative 5i. And my last term is negative times positive, which is a negative, I times I, which is I squared. Okay, I'm going to keep going. So I have x squared. Now I'm going to be able to do some combining and some crossing off. So I have x squared I just took care of. I have negative 5x, negative 5x. So that gives me negative 10x. And then I have negative ix here and positive ix there. So that's going to zero out. And if I look at just my i's, I have positive 5i and negative 5i, so that's going to zero out. This negative I squared is the same thing as 1. So the last terms I need to kind of combine there is 25 and 1, which is positive 26. Okay, so now I need to multiply them. I've cleaned up a lot, but I'm asking for the polynomial, so I need to multiply these together. So I'm going to take x times that trinomial, and then I'll take that plus 1 again times that trinomial, and I'll distribute. So I have x to the third minus 10x squared plus 26x plus x squared minus 10x plus 26. Combine in my final step, my like terms here. So I have x to the third, and I have negative 10x and positive x squared. I'm sorry, negative 10x squared and positive x squared gives me negative 9x squared. And I have positive 26x and negative 10x gives me positive 16x plus 26. So that is my final polynomial given the solutions that I started with. Okay, great job today. Thanks again for stopping by.